Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And here is my profile. I am Jeetendra Dixit. So I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. I have worked with various national level institutes in Delhi, Mumbai, and Lucknow. And I teach mathematics, and I was taking sequence and series, right? So we'll continue that sequence and series, and today I'm going to discuss means, arithmetic, geometric, and harmonic means. So we'll discuss it, but before that, let me check my sound and so yeah, sound is seems good. Wait a minute. All right, so let's continue. So before starting today's topic, let me tell you about the Unacademy subscription. So if you subscribe to Unacademy Plus, so after taking subscription, you can access daily live classes of all the educators who are taking courses on Unacademy platform. All right, and you also get their recorded lectures. So live and recorded lectures you will be able to access once you get the subscription. So this is what we when you get the subscription, and this access is unlimited. That means you can follow any educator. First of all, second, so there are some live sessions free also, which are special classes, YouTube videos, right? So like this session is a free session on YouTube, right? Educators are teaching on Unacademy's YouTube channels, as well as they are taking special classes. The special classes are free classes, and all the educators, it's not separate. All the educators who are taking courses there, they are also taking special classes. So special classes are completely free. You can attend unlimited special classes on the platform, and by doing that, you'll get to know the feel of the platform. You'll come to know how to interact with the educator, how to chat, how to ask your doubts. All right. So all these things um, you will get once you first you download the Unacademy's app and then attend special classes or take subscription to get unlimited access. Unlimited access. All right. Test series and quizzes are also quiz feature is also there, which is free. So there are many quizzes going on YouTube as well as on Academy's learning app. So you can attend those quizzes also. The quizzes are also free, but live test series and live test you get when you are subscribed to. All right. So there are test series is going on and assignments, DPPs. So many things are free and many things are on Unacademy's uh, platform, which you get after getting the subscription. All right. All these courses are well structured. Well structured means everything is pre-planned. So when you see the schedule of any educator, if you're following an educator, if you're following his course, then you will get to know you can just go through the educator's profile and you can see the schedule of all the upcoming lectures in well advance. All right. So which topic will be on which date that you can access easily. All right. That you'll get to know easily. So these are the things about the Unacademy's platform. You can download this Unacademy's learning app from Play Store. All right. And after downloading this, you can get subscription for 1, 3, 6, 12, and 24 months. These are subscription charges you can see. So let me highlight. 12-month subscription is 38,524. I'm going to circle these two because you can see economically these two are the best packages. All right. So after 10% discount, you'll have to pay only this much, 34,650 for 1 year and 50,400 for 2 years. All right. And you can get 10% discount. You can use my code JEET1 to get instant 10% discount. All right. So this was about the subscription. Now let's begin today's session. So as I told you, we are going to discuss means today, arithmetic, geometric, and harmonic means. So what are these means? Let's discuss it. So I'll start with arithmetic mean. All right. and then we will discuss geometric mean and harmonic mean and their properties as well. All right. So we'll complete the theory today, and if we'll get time, then we'll discuss some examples as well. All right. One minute. So before going ahead, let me check my voice because there was some problem yesterday. All right. So uh, first we'll discuss arithmetic mean. So what is arithmetic mean? I hope you must be. Arithmetic mean is a very basic thing which most of you know, right? It's an average. Okay. But let's discuss it. Okay. Let's begin. Uh, Hello, Harshita. How are you? So we are discussing arithmetic, geometric and harmonic means today. So let's discuss it. If you have two numbers, arithmetic mean or you call AM, arithmetic mean of two numbers. Let's just start with two numbers, then we'll take the arithmetic mean of n numbers as well. So arithmetic mean of two numbers, A and B, that we have already discussed is nothing but if you write it A, then that is A plus B by 2. All right, that is the arithmetic mean of two numbers. So if you want to visualize it, then let me tell you, if you plot these two numbers on number line, this is A, this is B, then arithmetic mean just falls at the midpoint. Okay, it is the midpoint basically. It is the midpoint of A and B. So this is A plus B by 2, arithmetic mean. All right, the midpoint. So through number line, we'll try to understand arithmetic and geometric and harmonic mean, their positions as well, right? So we can compare them also. Okay, now let's discuss arithmetic mean of n numbers. Then we will insert arithmetic and arithmetic means between two numbers. All right, like two arithmetic means, three arithmetic means. So before that, we are doing single arithmetic mean of two numbers and more than two numbers. So now, if you have arithmetic, you have n numbers. So arithmetic mean of n numbers, A1, A2, A3 and so on up to AN. So that is if I write A, that is basically A1 plus A2 plus so on up to AN divided by N. All right. So you can write this sigma of I from 1 to N. This is another way of writing summation A1, A2, A3 up to AN sigma that we will discuss later divided by N. All right. So this is arithmetic mean. Again on number line, if you want to see, then this is A1, this is A2 if I write these numbers in increasing order. So this is the increasing order. Then A will be somewhere between first and last, all right? First and last. It will always lie between first and last. That means smallest and the biggest one, all right? Between those two. But not exactly the midpoint of those two in this case, all right? Because you have many other numbers in between whose average you have taken. So this was the arithmetic mean of two numbers and n numbers. Two numbers arithmetic mean of two numbers already we have discussed previously. Now, what is the main thing which we are going to discuss today is inserting n arithmetic means between two numbers. All right, so let's start that. Insert n arithmetic mean. So that is the main point of discussion today. Insert n arithmetic means between A and B. So A and B are two numbers and we need to insert n arithmetic means between these two numbers. All right. See what will happen if you insert these two, n arithmetic means between these two numbers. So I'm plotting these two numbers on the number line first of all. So this is A and this is B. If you insert one arithmetic mean between two numbers, then this number line will be divided into two parts if you are inserting one arithmetic mean. If you are inserting two arithmetic means between two numbers, then this number line will be divided in three equal parts. This is first arithmetic mean, this is second arithmetic mean, all right? And these numbers A, A1, A2 and B will form an AP. Okay, these numbers will be AP, these numbers will be in AP. Similarly, if you are inserting three arithmetic means, then number line will be divided into four parts. And if you are inserting n arithmetic means, then in how many parts this number line will be divided? So if you are inserting n arithmetic means A1, A2, right, and A3, and so on up to AN, all right. So how many parts? This number line is divided into n plus 1 parts, all right. Then what will be the length? Total length is b minus a, right? Total length. This length is b minus a. So now A, A1, A2, A3 up to AN and B will be in AP. And what will be the common difference? Common difference is nothing but this distance between any two consecutive numbers, right? So what is that? Total distance was B minus A. Now what is this distance? This will be B minus A divided by total number of parts, that is n plus 1. So we have got the common difference. Okay. So in this way, you can write the common difference easily, right, by this logic. There are other ways also. I'll tell you both the ways to find arithmetic mean. So let's write it. Let A1, A2, A3 up to AN are n arithmetic means between small a and b. All right. This implies that A, A1, A2, and so on, AN and B will be in AP. If you are inserting, as I told you, if you are inserting one arithmetic mean, then A1 and B will be in AP. If you're inserting two arithmetic means A1 and A2 between A and B, then A1, A2, A and B. Okay, in this particular order, they will be in AP. Similarly, if you're inserting n arithmetic means and these two numbers. So total n plus two numbers will be in AP. Will be in AP. Okay, and what will be the common difference? So let common difference is D. Then D is what we have written it here, B minus A divided by B divided by n plus 1, because total length was n b minus a, and we have divided this number line into n plus 1 parts, right? N plus 1 part. You can see when you're inserting one arithmetic mean, it is divided into two parts. When you're inserting two arithmetic mean, it will be divided into three parts. And when you are inserting n arithmetic mean, it will be divided into n plus 1 part. And length of each part is b minus a upon n plus 1, all right? So that will be the length. Are you guys getting it? Okay, there's another way also. Another way of doing it is basically you can write this b is basically n plus 2th term of the AP, right? This b last term is basically n plus 2th term of the AP, all right? So you can write b in terms of a and common difference. So b last term is equal to first term plus number of terms, that is n plus 2 minus 1 into d, right? That is the formula. So from here also you'll get d. So d is equal to b minus a divided by n plus 1. So you'll get the same d, right? So this is another way. This is another way of getting the common difference. So now you have got the common difference. Then what will be a1? Your first arithmetic mean. So arithmetic means, okay, now we can write the arithmetic mean. So arithmetic mean A1 is nothing but A first term which was given plus D which we have got, right? Which we have found. So A plus D. And what will be A2? A2 will be A plus 2D. A3 will be A plus 3D. Or if you write arithmetic mean, that will be A plus RD. Simply you can remember this, right? So you need to remember two things. What? Whenever he is asking you to insert n number of arithmetic means between two given numbers, immediately write the common difference d, that is b minus a upon n plus 1. And then if he is asking you the rth or like fifth arithmetic mean or sixth arithmetic mean, okay, sixth arithmetic mean is the seventh term basically of that sequence if you are writing the sequence of AP, all right? So sixth because first arithmetic mean is basically second term, right? You can see that first arithmetic mean is the second term, second arithmetic mean is the third term. So rth arithmetic mean is r plus 1th term of the AP. That's why you are getting rth arithmetic mean as a plus rd. All right. So it's easy to write arithmetic means. A particular arithmetic mean if he is asking. All right. We have a property also related to arithmetic means. I'll tell you that property. But before that, let's do one example. So what is the example? Insert 5 arithmetic means between 1 and say 6. All right, smaller number. So okay, see the solution of this. So if you need to insert 5 arithmetic means between, okay, look at this example. So I'll write the common difference, okay. So common difference will be 6 minus 1 divided by 5 plus 1. So that is my 5 by 6, all right. So 5 by 6 is the common difference. Then what is the first arithmetic mean? First arithmetic mean is first number, which is 1 plus d. So that is 1 plus 5 by 6. So what is this? This is 11 by 6, right? Then what will be A2? A2 will be 1 plus 2d. So that is going to be 16. 1 plus 10 by 6. So that is 16 by 6. Then A3 will be 1 plus 3d. So 1 plus 3d, again this again add this d in this. So d is 5 by 6 again. So it will be, it is now keep adding 5 to the numerator. All right. Keep adding 5 to the numerator. All right. So that is going to be 21 by 6. Then you can write A4. A4 is equal to 1 plus 4d, and that is 26 by 6. And A5, the last one. All right. We have inserted 5 arithmetic means. So this is the fifth one, 1 plus 5d, and it is going to be 31 by 6. And this B, last term is nothing but 6. 6, you can write 36 by 6. Okay. So now you can see, I make the denominator same. And A, first term you can write as 6 upon 6. All right. So your sequence, what is the sequence now? So his first term was E, this is 1, see. Then it was 11 by 6. Now you can see the AP, all right. And this 16 by 6. And the next is 21 by 6. And the next is 26 by 6. And then next is 31 by 6. And the last one, which was given B, our B number. So that is 36 by 6, all right. So this number was given, these two numbers were given, and we have inserted these 5 arithmetic means. All right. So I hope it is clear. This method is clear to everyone how to insert an arithmetic means. All right. Now let me tell you one finest property of arithmetic means. All right. And you need to remember it. Shall I move? So far good to everyone. Rachita said yes. All right. Okay. So, all right. Then what we will do now, I'll tell you the property, but before that, mhm, 1 minute, guys. See, the first and very important property which we need to remember is this. If n arithmetic means are inserted between two numbers C and B, then sum of all the arithmetic means, is equal to n times a plus b by 2, which is single arithmetic mean, right? So n times a. A is single arithmetic mean between A and B, all right? So let n arithmetic means are, let n arithmetic means are, let n arithmetic means are a1, a2, a3 and so on up to an, then basically he is asking us to prove that a1 plus a2 plus up to an is equal to n times a plus b by 2. All right, this is what we need to prove. Okay, so let's see how to do it. Let me write the solution. Uh, First of all, as I told you, what is the common difference? Common difference D is equal to, let me change the color. So common difference is equal to B minus A. Common difference D is equal to B minus A divided by n plus 1, right? So what is your A1? A1 is equal to 1 plus D, A plus D, sorry, A plus D. A2 is equal to A plus 2D and so on. AN is equal to, last arithmetic mean is equal to A plus ND, alright? So this is, I hope, clear to everyone. Um, hello Subhash, alright? So let's add these arithmetic means. So let add, after adding these n arithmetic mean a1 plus a2 plus so on up to an, what would you get? You would get a plus d, a plus 2d and so on up to a plus nd. And a you can write, so you have written a how many times? You have written a n times, right? So that is going to be n into a plus what? Plus d plus 2d plus 3d and so on. All right. So if you add d plus 2d plus 3d, so you can take d common, it will be 1 plus 2 plus 3 and so on up to n. Sum of first n natural numbers and that you know all, you guys know, right? So it is n into a plus, now you can put the value of d also, that is b minus a divided by n plus 1, as well as put the value of this summation 1 plus 2 plus 3 up to n. So what is that value? That is n into n plus 1 by 2. All right, so you can cancel n plus 1, all right, and add them. So we are getting the answer na plus b minus a into n by 2. Now take the LCM. So take LCM is 2, so it is going to be 2na plus bn minus an. All right, so it is going to be a plus b and n you can take common n by 2. Yes, that is what we were supposed to prove. We were supposed to prove that sum of n arithmetic means is equal to n times the single arithmetic means. N times the single arithmetic mean. So suppose, I hope it is clear. What about you guys? Subhash and I think Harshita. Is it clear to you guys? Let me know any doubts. Harshita, okay. So, all right, let me give you one example then. We find the sum of 10 arithmetic means inserted between 10 arithmetic means inserted between, take any two numbers 2 and 8. All right, So in this case, you don't need to find the arithmetic means. Okay, do not try to find 10 arithmetic means, all right, and then add them. No, no, no. Don't need to do that. Just use the property which I just discussed. And what was that property? Sum of 10 arithmetic means A1 plus A2, let A1, A2, up to A10 or 10 arithmetic means is equal to 10 times of single arithmetic mean. So what is single arithmetic mean? 2 plus 8 divided by 2, A plus B by 2. Simple. So what is the sum? It is going to be 50, right? So 50. I hope this example is clear. We were just trying to apply that property which we have proved just now. All right. So let's discuss the theory of geometric mean, also geometric mean and harmonic mean. Then we will discuss examples. All right. So let me tell you geometric mean as well. Geometric mean. So first of all, single geometric mean of two numbers, two positive numbers. Let me clear, because geometric mean is defined for positive numbers only, two positive numbers. Although sometimes the students argue that if you take both the numbers negative, then their product will be positive, and then you can take a square root, because geometric mean of two numbers is under root of AB, under root of AB, if A and B are the numbers. Then they ask under root of AB is defined when A and B both are negative. But no, when you have, that will be defined, but that won't be geometric mean. This is what I want to say. All right, like -2. Because whenever you take mean of some two numbers, it always lies between the numbers. All right, so that is not a mean. That is not defined as geometric mean. All right, so geometric mean is defined for positive numbers only. So two positive numbers A and B. Let's take it G, and G is nothing but under root of AB. All right, so this is the simple geometric mean, and it falls on the number line. If you want to see it, then it is, if this is the midpoint, then it is slightly less than, this is the midpoint. All right, this was the arithmetic mean, and here it will be geometric mean. It is smaller than the arithmetic mean. All right, so it is smaller than the arithmetic mean. This is the geometric mean. I hope it is clear. Let me define this, let me explain this in a geometrical way. What is that? Suppose you have a rectangle, all right? And what is the geometrical significance of this geometric mean? See, if you have a rectangle whose sides are A and B, say B is greater than A, so this is B and this is A. Then what's the area of this? Area is A into B, okay? Now I am asking you to form a square with same area, then what will be the side, right? See, here sides of this rectangle are A and B, right? I'm asking you to form the area, form a square with the same area, that of this rectangle. Then what will be the side of that square? All right. So that side of a square is basically geometric mean of sides of this rectangle. All right. So if I ask you to form a square, this is a square with same area, that is A into B, then what will be the length? This length D. So D is nothing but, D square is the area of this square, and that is equal to area of this rectangle AB. So this is the average, right? So in this way, so whenever you have a rectangle, geometrically you can explain like this. There are other ways also. Like if you have a rectangle of side 20 and 10, and you have a slab, right? And you want to form a square, then what should be the length of that square, side length of that square? So it is basically, it is not the average, it is not the arithmetic mean, it is the geometric mean of sides of that rectangle. All right, So if you take the geometric mean of 10 and 20 and the side length you're getting, using that side length, if you can form a square, you're making it a regular polygon, right? You are making it a regular polygon because you have taken a mean, all right? So using that mean, you can form a regular polygon. So it is significant in geometrical sense, all right? I hope it is making sense. So D is nothing but under root of AB, all right? So, okay, it is good just to understand what actually we are doing in geometric progression, in geometric mean. Because arithmetic mean is simple to understand. That if one person has 10 rupees and another person has 20 rupees, you have taken their money from both of them, and you have added the money, and then now you are equally dividing them. So what is that number? That is arithmetic mean of these two numbers, 10 and 20, right? So you have taken these two numbers, you have added these numbers, then you have equally divided these numbers, these rupees or money, to back to these two persons. So now they have the average, equal numbers and equal price, equal money. That is called average, right? Arithmetic mean. Okay, let's continue then. Uh, Geometric mean of n numbers, n positive numbers. So let numbers are, let a1, a2 and so on, an are n positive numbers. Then their single geometric mean is defined as a1 into a2 into a3 and so on up to an. So for two numbers, you took the product of a and b and whole power 1 by 2. For n numbers, it will be power whole power 1 by n. Multiply all the numbers and take nth root. All right, take nth root, and that will give you the single geometric mean. So this is the formula for single geometric mean. I have one example for this single geometric mean. So let's discuss that example first. Suppose this is the example. We need to find the single geometric mean of these numbers. All right. So let's do it first. You try it. Try to find the geometric mean. Let me tell you the formula again, if it was quick. If you are taking the single geometric mean of n numbers, all right, n numbers, these are n numbers, then what you have to do, what you have to do, you have to multiply all the numbers. You'll have to multiply all the numbers and take nth root, all right? Like if you need to take geometric mean of three numbers, say 1, 3 and 9, then what is the geometric mean of these three numbers? Geometric mean is 1 into 3 into 9 whole raised to 1 by 3. Okay, so it is coming out to be 3 because I have taken numbers in such a way, all right? Cube root. So cube root of three numbers. If you have four numbers, then that will be fourth root of product of four numbers. If you have five numbers, it will be fifth root of product of five numbers. So similarly, if you have n numbers, it will be product of nth root of n numbers. So this is the example you need to do. We need to find geometric mean of these n numbers. So try to find it. Okay, Harshita is saying B. Any other answer? Then let me discuss. Suvash is also getting B, all right. So geometric mean G is nothing but it is 3, multiply all the numbers. So 3 into 3 square into 3 cube and so on up to 3 raised to n. and whole power 1 upon n, because you have n numbers. You can see 3 raised to 1 to 3 raised to n. So you have n numbers, right? Now, how to multiply these numbers? Because base is same, so you can add the powers. So if you add the powers, powers will be 1 plus 2 plus 3 and so on up to n whole power 1 upon n. All right. Then it is going to be 3 raised to, write the sum of these n numbers, so that is n into n plus 1 by 2, and powers will multiply, so it is 1 upon n only. So n and n will get cancelled, and yes, you guys are correct. So this is 3 into 3 raised to n plus 1 by 2. All right. So that is the answer. All right. Now let's come back to geometric mean. Now we will insert n geometric means between two numbers. So see how to do it. Do that. N geometric means, insert n geometric means between two numbers. So insert, how to insert n geometric means the similar way which we did in arithmetic means. So let G1, G2 and G3 and so on up to Gn are n geometric means, between A and B, all right? Between A and B. So these are the numbers in which between these two numbers we need to insert n geometric means. So I'll write the number, then this means E, G1, G2, G3 and so on up to Gn and B will be in GB, because whenever you insert a geometric mean between two numbers, they will form a GB. If you are inserting one geometric mean between two numbers, then these three numbers will be in GB. When you're inserting four numbers between two numbers between A and B, then you'll get sequence of four numbers and they will be in GB. Similarly, if you're inserting n geometric means between A and B, then they will form a GB of n plus 2 numbers will be in GB, all right? And which number is this? N plus 2th number, all right? N plus 2th term. So we need to find common ratio to find G1, G2, G3, right? So let common ratio is equal to R. So you can apply the formula. What is the formula for n plus 2? This is n plus 2, right? N plus 2th term is equal to first term into common ratio to the power number of terms, okay, minus 1. If you're writing rth term, nth term, it will be ar raised to n minus 1. If you're writing n plus 2th term, it will be ar raised to n plus 2 minus 1, all right? So an plus 2 is nothing but b, so b is equal to a r raised to n plus 1, and then r you'll get b upon a raised to 1 upon n. So it is 1 upon n plus 1, sorry. So it is similar to that, like in arithmetic mean you were getting b minus a divided by n plus n. In this you are getting b upon a whole to the power 1 upon n plus 1, n plus 1. So n plus 1 is common in both the terms, right? Common difference and common ratio, right? So if you are inserting five geometric means, then what will be the common ratio of this GB? That will be last term upon first term whole raised to 1 upon 6. 1 upon 6. If you are inserting five geometric means. If you are inserting say 20 geometric means between two numbers A and B, then what will be the common ratio? Common ratio will be B upon A raised to 1 upon 21. If you are inserting 20, it will be 21. Do remember that, all right? So in this way, you can write first term, first geometric mean G1 is equal to A into R. So A into R. Now you can put the value of R. We have got R, right? So I'm writing in terms of A and R. Now G2 will be what? A into R square, because G2 is nothing but third term. So you'll get power 2. Okay. So in this way you can relate it. And if you want to write mth or nth geometric mean, that will be A R raised to M. So this is general formula, all right? So to write the values, to write the geometric means, what you need to do is you need to write common ratio immediately, and then whatever geometric mean he is asking, you can just use this formula, like find fifth geometric mean between 27 and 81. If 6 geometric means are inserted. All right. So this is one simple example. Let's solve it. See what is the solution. As I told you, first immediately we'll find R common ratio. So what will be the common ratio? Common ratio will be actually let's write it. This is 1 upon 27. All right, 1 upon 27. I'm just making the calculation easy, nothing else. All right. So it is 81 upon 1 upon 27, all right, whole raised to 1 upon number of terms you can see 6 geometric means, so it will be 6 plus 1, all right. So what is this? This is going to be 3 raised to 7 whole raised to 1 upon 7. So it is going to be 3, right? You have got R3. So what is the fifth geometric mean? G5. That is A into R raised to 5. All right. So what is your A? A is 1 upon 27 and R is 3 raised to 5. All right. So 3 raised to 5 upon this is nothing but 9. Right. So your fifth geometric mean is nothing but 9. I hope it is clear. Now one property, one important property or important point. See, all those properties will be valid, which like there also I should say that in arithmetic means also all those properties will be valid which were true for arithmetic progression, right? So those properties are common, and that the one property which we discussed was exclusive property for arithmetic means, all right, sum of n arithmetic means. Here also we have one exclusive property for geometric means, and what is that? We need to learn that. So property is that uh, if and geometric means are inserted between A and B, then their product is equal to their single geometric mean to the power n. All right, single geometric mean means G. If you call G, and or you can write G is nothing but under root of AB to the power n. All right, nth power of single geometric mean. In arithmetic means sum of n arithmetic means was n times the single arithmetic mean, and geometric mean product of n geometric means is equal to nth power of single geometric means. All right, so let G1, G2, and so on up to Gn are n geometric means between A and B, then what we need to prove is this: G1 into G2 into G3 and so on up to Gn whole raised to, no, not whole raised to, this product is equal to single geometric mean raised to n. All right, that means under root of AB raised to n. This is what we need to prove. All right, let's do it. Proof. Okay. So first of all, let common ratio is equal to R. So we can immediately write R. R is nothing but B upon A raised to 1 upon n plus 1. We learned that, right? So we are using the same thing. Now let's write G1 into G2 into G3 and so on up to Gn. So we'll put the values of G1, G2, G3 up in terms of A and R. So first is AR, then AR square, then AR cube, and so on, AR raised to n. Then you can write A raised to n and R raised to 1 plus 2 plus 3 and so on. So I've collected all the terms of A and all the terms of R. So powers will add up. So you'll get A raised to, so this product G1, G2 and so on up to Gn is equal to A raised to n, and this is R. R is what? R is what? Now we need to put, okay, I'll put the value n into n plus 1 by 2. So let's put the value of n, R, sorry. So value of R is nothing but this one, B upon A raised to 1 upon n plus 1 and whole raised to n into n plus 1 by 2. So you can see this n plus 1 will get cancelled because powers are going to be multiplied, right? So we are getting a raised to n and b raised to, you can write b raised to n by 2. B raised to n by 2 upon a raised to n by 2 also, right? So now you can write this product is equal to a raised to n by 2, b raised to n by 2. So you can write a into b raised to n by 2. 1 by 2 you can take again inside, so that is under root of ab raised to n. All right, so this is the product and hence proved. So if you need to find the product of n geometric means between two numbers, product of n geometric means between two numbers, then no need to find the geometric means individually. You can directly use this formula, find their single geometric mean by taking the square root of their product and put n power. All right, if you have 5 arithmetic means, then put power 5 and so on. All right, so I hope it is clear. Now let's discuss harmonic mean also, and then we will so I'll keep a separate discussion, separate practice session for this. All right, let's finish the theory today, and we'll discuss problems later. All right, on these means, because we have very good problems on means also, and these are important as well. So let's insert harmonic mean. So single harmonic mean, single, same process, single harmonic mean, then harmonic mean of n numbers, and then we'll insert n harmonic means between two numbers. All right. So single harmonic mean of A and B is nothing but 2 upon 1 upon A plus 1 upon B. That means we first take the reciprocals of the numbers, then we take their arithmetic mean, and then again we take the reciprocal of arithmetic mean. So that becomes the harmonic mean. Listen to this again. First we take the reciprocals of the numbers, then we take their harmonic. First we take, let me write it here, what I'm saying. First we take the reciprocals of the numbers, then we take their arithmetic mean, then again we take their reciprocal. All right, and what we get harmonic mean. Okay, so that is the process. So using this process you can write, so if I simplify, if let common ratio harmonic mean is h, then h is nothing but 2ab upon a plus b. So this is the formula of single harmonic mean. So if you insert this harmonic mean between these numbers, these three numbers will be in HP, harmonic progression. All right, remember this. This is the first point. Second point is uh, harmonic mean of n numbers. Say a1, a2, and so on up to an. And there's no restriction like we had in geometric mean that numbers should be positive. There's no restriction in arithmetic and harmonic means. All right. So single harmonic mean is nothing but first take the reciprocal of all the numbers, then they take their first take the reciprocals of all the numbers. All right. I'm telling you the process. Then take their arithmetic mean, and then take reciprocal of this arithmetic mean. You'll get harmonic mean. You know arithmetic mean and harmonic mean relation. So it is n upon. See, it was 2 upon. Now it is n upon 1 upon a1 plus 1 upon a2, and so on up to 1 upon an. All right. This. Suppose you have three numbers harmonic mean of 2, 3, and 4. Then what is the harmonic mean? Harmonic mean is equal to 3 upon 1 by 2 plus 1 by 3 plus 1 by 4. Okay. So if you simplify it, you'll get the harmonic mean. So I hope it is clear. Harmonic mean of 3 numbers, 4 numbers, 5 numbers, single harmonic mean. Now let's insert n harmonic mean between these between two numbers. So how to insert n harmonic mean? It is simple actually. It is similar to arithmetic means only, because we know what is the relation between arithmetic mean and arithmetic progression and harmonic progression. So insert n harmonic means between A and B. All right. let H1, H2, so A, H1, H2 and so on up to Hn and B. These are n harmonic mean betweens. So they will form HP, alright. Now to solve HP. To find H1, H2, H3, we'll have to make corresponding AP, right? So immediately write, then this implies 1 upon A, 1 upon H1, 1 upon H2 and so on, 1 upon Hn and 1 upon B. They will form an AP, alright. Now we have got AP, so you can write common difference. So common difference, let's take common difference D. So D is nothing but, see, I've told you the common difference of arithmetic mean, right? So these are n plus 2 terms, so common difference will be 1 upon B, last term minus first term divided by n plus 1, alright? The same formula which we used in arithmetic means, okay? So these are basically n arithmetic means, 1 upon h1, 1 upon h2, 1 upon hn are n arithmetic means between 1 upon a and 1 upon b. So what will be the common difference of this AP? Last minus first upon n plus 1, okay? What we discussed in arithmetic progression. So I hope it is clear. Now as we have got what's the common difference, we can write any term, right? So what is 1 upon h1? 1 upon h1 is nothing but 1 upon a plus d. That means h1 you can write h1 is 1 upon a plus d. Similarly, you can write h2. h2 is 1 upon a plus 2d and so on. You can write hr. Rth harmonic mean is 1 upon a plus rd. All right. You know what is r. So keep putting in this. This is the formula for rth harmonic mean. Right. So I hope it is clear. Like one of the very important property we proved in arithmetic means, we can use that property here also. Properties. See in this. These are arithmetic means. So sum of all the arithmetic means, matlab 1 upon h1 plus 1 upon h2 and so on up to 1 upon hn is equal to n times the single arithmetic mean of these two numbers, n times single. We are using the same property which we used in arithmetic means. Alright, so we are using the same property. There's another property also which I'll tell you. Okay. So that is single arithmetic mean, that is 1 upon a plus 1 upon b by 2. So of course you can use it, alright, by 2. So this is one of the property, and the next property is very important, and they ask in, mostly you'll see this advanced level problems based on that. So I'll tell you the property which relates arithmetic and harmonic means. Alright, so now let me tell you the property. Okay, we'll practice later in next session. Okay, not next, but I'll keep a separate session because it's already planned. Next time I'm going to discuss geometric, arithmetico-geometric progression, but I'll keep a different practice sessions based on different topics which I have covered so far. Okay, so let's cover the theory first. If A1, A2, A3 and so on up to AN are n arithmetic means between A and B, and H1, H2, H3 and so on up to Hn are n harmonic means between A and B, then this is the property. Property is this: A1 into Hn, first into last, is equal to A2 into second last harmonic mean, that is n minus 1, and so on. If you take rth arithmetic mean from the beginning, then rth from the last, rth harmonic mean from the last, which will be basically rth from the last will be n minus r plus 1th, because you have n arithmetic harmonic means, n minus r plus 1th will be from the beginning. This is rth last harmonic mean. which is n minus r plus 1th from the beginning. All right. Harmonic mean. All these products is constant and this is equal to a into b. All right. This is the property. Very, very, very beautiful property. All right. So if you're multiplying first arithmetic mean and last harmonic mean, it is nothing but the product of the numbers. All right. Let me prove it. So obviously you can take first and so what is the common difference? Common difference of AP. Common difference of AP. Let's take as D1. So D1 is nothing but B minus A upon n plus 1. And common difference of corresponding AP, common difference of AP corresponding to HP. All right. Corresponding to HP, which will form this AP. A 1 upon A, 1 upon H1, 1 upon H2, all right, and so on, 1 upon Hn and 1 upon D. So its common difference is D2, all right, and this A1, A2, and so on up to An and B. This common difference of this. So what is D2? D2, I'm writing D1 and D2 because we need D1 and D2 to write HR and Hn minus R plus 1, okay. So let me do it fast. So it is 1 upon b minus 1 upon a divided by n plus 1. If you simplify, it is going to be a minus b upon ab into n plus 1. All right. This is the common difference. So now you can write AR. I'm writing the general term, these terms. Okay. So if this product is okay, then you can write R is, then you can put R is equal to 1. So you'll get H1, A1, Hn. Keep putting the values of R. All right. So what is AR? AR is nothing but A plus D. So A plus D is A plus D is what? B minus A divided by n plus 1. Let's simplify it. So it is going to be n plus 1 into A plus B minus A divided by n plus 1. All right. So it is going to be n into A plus B divided by n plus 1. Okay. So we have got actually R. Oh, I'm sorry. I forgot R. Let me correct it. We are writing AR, not the first term. So it is A plus RD, all right. So A plus RD, so that is going to be A plus R times of B minus A divided by n plus 1. Okay. So it is going to be n plus 1 minus R into A, all right. Yeah. Plus RB divided by n plus 1. Okay, so this is AR. Now let's write HR. So we can write HR or 1 upon HR you can write at least. Let's write 1 upon HR first. So 1 upon HR is 1 upon A plus, not HR, I'm sorry, HN minus R plus 1, right? We need to write HN minus R plus 1, this term. Okay, so I'll write this. Oh, what is that? So Hn minus R plus 1, that is equal to 1 upon A, first term, 1 upon A, this, plus n minus R plus 1 into D. D is nothing but A minus B, right? A minus B, make sure A minus B into A upon A into B into n plus 1. Let's simplify it, then we'll need to take reciprocal also, then we will take the product, all right. So it is 1 upon, what is the LCM? LCM is going to be AB into n plus 1, all right. Let's take the LCM. So it is going to be B into n plus 1 here and plus n minus R plus 1 into A and minus n plus 1 minus R into B. All right, let's simplify it. If you add this as well as this, n plus 1 into B will get cancelled and the only thing remaining is R into B, right? Plus this whole thing, n minus R plus 1 into A upon A, B, n plus 1. Take the reciprocal, we get 1 upon h. This is 1 upon h n minus r plus 1. Okay. So now I'm multiplying it. Now we have got the numbers. AR, I'll write it here. So let me make some space. So AR into Hn minus R plus 1. Put the value of AR. AR is what? N minus R plus 1 into A plus RB divided by n plus 1. And what is the value of HR? So I need some more space. Okay, so put the value of h of n minus r plus 1. So that is, take the reciprocals, it is going to be AB upside, AB into n plus 1 in the numerator divided by r into b plus n minus r plus 1 into a. All right, so you can see this will get cancelled, n plus 1 will get cancelled, and you have got AB. All right, hence proved. Done. All right, this is a very beautiful property. You don't need to remember this proving part, but at least remember the property, because they can directly they ask directly questions based on this. Okay, they can ask in advance also. So all right, thank you very much for attending this session, and we'll continue practice session later. Okay, after some time. So subscribe the channel and keep watching it. Okay, this is one of the finest channel of Unacademy for all the students who want to do their preparation in English. All right, and we'll cover everything in this. Everything means all the topics in detail with theory and lot of practice questions. Okay, so subscribe the channel and like my videos if you're enjoying it, and thank